We're here to review some of the top teams from the design event over the last 2.5 days. As you know, you all did design reports, you did drawings, 3D drawings, of course, and all the development of your vehicle. So what we did Thursday, of course, was going through all day in great detail. And then last night, we had design finals, which was 6 of the internal combustion cars and 3 of the EV cars. So this year we had a large number of EV cars. You might say it's the invasion of the EVs here. And we'll see how it's going to be in the future here in terms of EV participation. But by and large, the EV cars are quite a bit better than we've had in past years. A couple of notes on design before Steve and I get into this. By the way, this is Steve Fox, longtime design chief here.
And Dr. Dave Retz is design captain for Lincoln.
What we've always stressed with design, both in Michigan and here, is that this isn't just about the quality of the cars that we see. This is about what we see in the teams in terms of development, what they've overcome, what they've learned, okay? So at any point in time, you can see a car and say, well, mine looked better than that, or I should have been there. The reality is, it's a lot more with design than just the finished physical product you see. It's all the development work you do. Could you repeat a car that's consistent and reliable? Remember, the idea was if you're going to build 1,000 of these, would the designs be robust for an autocrosser? So most of all, it's about you're all learning. And I hope you guys learned a lot over the last year, or the last 4 years for you seniors, or 6 years, however many you've been here. So what we want to get into here is a few of the cars. We've got 2 of the EV cars and 2 of the internal combustion cars. On our far right here, stage right, is Texas A&M, which is a, yes, actually, I'm going to say something about Texas A&M, and then Steve will tell you a whole bunch of details on them.
Let's do it again. Texas A&M.
Hey. Texas A&M is a senior capstone team. This car didn't exist in any way prior to about September, even on the drawing board. And they have to start with their team build in the beginning of September.
The team didn't exist. This is not a carryover team. They do this each year from scratch, the hard way. They don't get successive years to do it like the rest of the teams here do.
So, Steve, you want to go into some of the details on this car?
Sure. I like this car a lot, and it really says a lot about Texas A&M that a one-year program made it to design finals and is sitting here in this tent tonight. Let's hear it for Texas A&M. The team doesn't even know who's going to be on the team and who they're going to work with until September. So last September was when this team formed and started working on this car. It's a tube frame car with a single cylinder engine. It's 378 pounds. It's got a really nice lightweight covering that's got a nice finish to it. It's a well-polished, well-finished car for being a one-year car. They also included an aero package, which, whenever I go out and talk to any of the students at their schools, I always advise students that you need a minimum of 2 students to start on an aero package because it's that much extra work. And in addition to doing all of the kinematics, load pass, suspension, design, frame, everything else for your car, you've got to then test the car without the aero package, get a baseline on it, then add the aero package in. It's a ton of work, and they did it in 9 months. It's pretty remarkable. Some comments that some of the design judges made over the last couple of days. It's nice and serviceable. The load pass are extremely well done. They paid particularly close attention to inertia loading and considered the fatigue as a result of inertial loading. This is a well-developed little car. They used the stock ECU and driveline, which for a one-year team makes an awful lot of sense. These students have to pay particularly close attention to make versus buy decisions because they don't have the time to throw away chasing down some kind of a manufactured part that they run out of time on. They're hard up against the time deadline on this thing. They did change the cams in the engine with the manifold. It's a tuned package, and it's considered as a whole. This is the way that we would prefer to see it done. The cam and valve train design judge was particularly impressed with that. They solved an oil pressure problem. The one bad thing that the judges had to say is they don't have any really good temperature data on it, but considering they did this whole thing in such a short period of time, you have to kind of overlook a few things. The map is well understood for altitude change, and there's a relationship there, and they understood it and took that into consideration. The brakes are well understood, as well as pedal compliance and brake feel. It's a well done little brake system. It's got great feel. It's a comfortable car to sit in. The only really bad thing we've got to say about ergonomics is our 5th percentile female didn't do well with any of the cars that she sat in last night. All 9 cars pretty well failed 5th percentile female. It's not a surprise to us design judges. It might come as a real rude revelation to all of you out in the audience, but it's just kind of the norm that we see. Most of the teams do not pay particularly close attention to fitting their car to a 5th percentile female. When you go to design finals, guess what? We bring in a 5th percentile female, so that's where we get you. Dave, did you want to talk about?
A couple things. One thing I'd like to shortly here is bring up Ryan and Hunter from Texas A&M. They're the project manager, Ryan. And Hunter is the suspension lead / crew chief. Okay, I'm going to ask you to tell us a little about your car in a second. Let's come up here. Put it up here so you can see him. Okay, ladies, Ryan here. Okay. Okay, you guys had 5 or 6 sub-teams that you used, and the strategy you told me earlier was about keeping things fairly simple because you had limited time to do it and you want to maximize some time for testing. Sure. Tell us what kind of compromises you made to ensure you got a car going as compared to having some pie-in-the-sky idea that wasn't going to work.
So pretty early on, the first couple weeks of our semester, we wanted to make sure and get our teams all set because we knew we needed to get a really good head start if we wanted to finish this in time to test as much as we could. So we set our teams. This is how we have done it in the past, and it's worked pretty well. We had a chassis, suspension, powertrain, aero, and electrical teams, and we split those up. We made sure and communicate really well, and we just set really hard deadlines for ourselves. Something else I'd like to mention, we had our rollout at South by Southwest in Austin, Texas. This was really a lot earlier than we typically have our unveiling event, and so this was kind of a motivation for the whole team to get the car done really early.
Also, some of the judges were impressed with some of the destructive testing that you performed. Want to comment on what you destroyed to learn?
So one of the things we were worried about the most was the eccentric loading of the push rod extender for the dampers, and so we destructively tested those. We also did camber shoes, and we did destructive testing on like the clevises for the control arms, all kinds of different things, just because we wanted to validate that our predicted loadings were realistic and that our components could handle what loads we predicted they would be able to.
What they actually did is completed their modeling a bit more in the FEA to right to destruction rather than just what the bending was going to be. So you got to see how far it really could go. I understand you did over 750 miles of testing. Is that right?
That's correct.
Okay. And what failed during testing?
All kinds of stuff.
You can fail a lot and still be up here. I'm saying, okay. Also, you did something here. Was when you welded your frame, you did something with regard to the welding patterns in terms of some reliability. Are you familiar with that as a chassis?
Yeah, you want to
It was a consistent welding pattern you used for making sure the welds are done properly?
So for welding the chassis, we developed a pretty simple jig. We had it laser cut out of steel, and basically we just bolted our suspensions tubes to this, and we just built from there. We have one of our team members, Hannah, who learned to weld. She didn't know how to weld at all in December, and she welded the whole thing together. And she did a really great job. So she's an expert welder now, and I'm really impressed.
Fantastic. Okay. The other thing you did is you did some brake temperature testing using a fairly innocuous thing, a lathe. You did your own brake temperature testing.
Yes.
Okay. Tell us about that. What did you discover?
So what we discovered was that we weren't ever going to be able to overheat our brakes, so that's what led us to just use a blank rotor that was as thin as possible, so it would be as light as possible, and then we could get the pads up to temperature as quickly as possible and get up to the maximum friction coefficient as quickly as possible.
The other thing I'd add is this car was designed for some serviceability in mind. They tried to make as many consistent parts, like left and rear, left and right uprights in the rear are done the same. Try to make the fasteners and so forth as similar as possible, so you didn't have to have a huge parts inventory of items. Your simulations for some of your aero work was well appreciated by the aero engineers as well. I will say this: there were a couple things they had. It's constructive criticism. You had really done a nice job with your attitude sensitivity studies with the wings. Okay, a lot of people don't do that. They look at wings in a straight, and the reality is the car is constantly at a yaw angle. Okay, what does your downforce look like at that? Typically lower. Okay. In fact, this car, even with that, you guys had an interesting situation happen out in autocross yesterday. Tell us about the bicycle you had out there, or motorcycle.
So that's my fault. We were on the practice track, and I was expecting to get some more time, but decided to go. What turned out to be the wrong way for tuning, which took a long time, and then we had to go out on autocross with a really bad setup. But then we got enough testing time today where we softened up the car and got a lot better for endurance, and got a stern talking to from the tech inspectors to ensure it did not come off the ground again, but we kept it on the ground.
We've had a number of cars today and yesterday that were bicycling out there on the track. And if you've ever seen one of these cars roll over, you don't ever want to see that again. So we maybe have to address that in some ways. We're looking at that. This track is interesting. We see similar things with some other converted tracks, not just for SAE, but professional racing, where the bumpiness of the track and the edges you can catch, between the concrete slabs can actually give you instantaneous impact loads, which are significantly higher than you would have anticipated, and you get into the overturning moment. And your car got up on two wheels, I think at least twice that they noticed, and we've got a photo of one that was up at about a 45 to 50 degree angle. Okay. Kudos to that driver for keeping it on the track. But obviously we're going to try to avoid having that in the future. It's going to happen as we keep going with narrower track widths, okay? You got to be very careful. Your rollover threshold becomes a much lower G-force. So, but the serviceability of your car is something that was got good kudos as well. The 5th percentile and 95th percentile ergo judges that went in thought that the seat was great, the control access was quite good. So it was well done. What I was going to say was negative about the, as I mentioned, the attitude sensitivity, is that there was a lot of pitch flexibility still in your rear wing, okay? And so the wing bounces around a little bit, okay? Over time, vibration, even if it's a lower frequency vibration, will break parts, okay? So you want to make sure you work on the stiffness of that upright. So but other than that, congratulations, great job, and we'll look to see a lot more success out of your team.
Thank you.
We're not taking these cars in any particular order tonight. We're going to keep you in suspense for a while longer. The next car I'm going to talk about is number 9, San Jose State University.
99.
This is also a tube frame car. It's got a thin fabric covering on it for a body. And it uses a Triumph 675 Street Triple running E85. The thing that I found most interesting about this is, and this is something I haven't seen yet in a student-built car, they did a 4-stage dry sump pump, which is housed in the pan and is driven by the cam chain. So it's completely internal. There's a bulkhead fitting that comes in and out to supply the dry sump tank and supply pressured oil to the engine. And it's a pretty incredible marvel of packaging. They turned down a dry sump pump from a well-known pump manufacturer. It happens to be a personal friend of mine. because they thought they could do it better, and I got to agree with them. I think they did. It's pretty remarkable. If any of you get a chance to talk to the team about their dry sump pump, I urge you to do so. It's pretty interesting. They use a very clean engine bay. Some of the comments from the judges. Very clean engine bay. Not like spick and span clean, but tidy. There's not a lot of clutter. Wiring harness is pretty well tied away like it should be. It's easy to find stuff. They have a fastener bill of materials for the car with as commonly sized fasteners as they can get away with and still meet fastener strength specifications. And they've got a torque spec manual that they built for the car. So anything in the car that needs to get tightened down, they can tell you exactly what the torque's going to have to be. They use a stock piston rod crank reciprocating assembly, which again is not exactly a bad thing if you're out of time. It's one of those make versus buy decisions again. You can do a highly modified short block, but it costs you more time, and then you got dyno development time on top of that. The comment that they made was that the restrictor is job one for them. They paid particularly close attention to the drag of the restrictor because they knew they wanted to get the maximum amount of air through this thing that they possibly could. They use an electric water pump, and they demonstrated really good ECU theory, and they can use the data. So they don't just collect it, they analyze it and figure out what it's telling them and make corrections accordingly. A lot of times we see students collecting the data, but they don't know what to do with it. Oh yeah, it's right here in the computer. Okay, what did the data tell you? I don't know. You got to use the data. Your engineers start figuring out what to do with all that wonderful data you're collecting and make it work for you. That's the trick. They, of course, did a torsional test, but they had really good justification for the torsion target that they achieved for the car. Frame is particularly well triangulated. Comments about the brakes, they did a good job relating the actual data to the pedal feel. Once again, this car has a well-developed set of brakes. It's pretty nice to be able to sit in the car and push on the brakes, and the brakes work. One of the other things that they demonstrated the knowledge of, which a lot of teams really don't quite understand because they don't take it to quite this level, they have a very clear understanding of the seals that are in the brake calipers, and particularly demonstrated the fact that the piston has rollback, and it's a function of the seal that you have in the caliper that does this, and this is what keeps the brake pads from dragging on the rotor. It's good seal design. They incorporated that into their calipers and had a very clear understanding of it. So, car 99, I like this one a lot. If I had to get into a car and drive it fast, I think I could drive this one pretty darn fast. Dave?
Okay, again, this team worked hard at servicing the car. As much as they put in here, and it's packed. If you look through, there's a lot of different subsystems they've done on here. They made it fairly easy to service. The engine bay, they can remove the engine in a pretty short time, and they use a single harness disconnect for the whole motor. Okay? Any of you after try to swap motors, particularly Triumph triple motors, you're going to see wiring all over the place that you got to sit there and rehook up. They did one plug disconnect. So they worked hard on the servicing there. The other thing they did was interesting. They bought some wheel centers and discovered they weren't concentric. Why would that be a concern? Okay. So they did some testing on that, and it tells you don't always trust what the vendor gave you. You got to be checking that. So they made sure that they had wheels actually were turning fairly round, which was nice to have. Their data looking on track, and actually the modeling they did was phenomenal. It was done very, very well. They had an interesting wing arrangement, the double plane, the biplane wing up front, which gave a lot more chord length to work with, a lot more wing area. I'd like to bring Fabrice and Sam up here if you can. Are you here? Fabrice is the EV and data focus, and Sam handled more of the chassis and controls. Okay, I want to ask you a couple things. When I met with you a little bit earlier, one of you blurted out, We finally started using load cells. Why was that important?
Yeah, so this year's car incorporated push and pull rod load cells. We used it mainly early on to get our setup down. So we had steady state lateral load transfer distribution, and that kind of drove the balance of the car, as well as other things with our data. But yeah, they were there to also validate load cases for the car as well. Yeah.
Okay, well, sometimes when you're on the data side, there's always something you'd like to measure, and there never seems to be enough budget for it. Not just financial budget, but human resources to do it, or just reluctance. Like, what do you want to do that for? That's just going to add more weight, okay? You guys work together as a team pretty nicely. I thought that was really great, the dynamic you have. But they said something else. They have a team of sponsors, okay? And you actually treat your sponsors like they're part of the team. They're not just a group that brings, big wads of cash in. It's not always money. Sometimes it's in kind and so forth. What are certain things you do to entice sponsors to be part of your program, to be on your team?
Yeah, so some of the things we do with sponsors is we have like sponsorship dinners, try and invite them out, get a look at the new team every year. We start with in the fall semester, usually do that. That way they can kind of see the new incoming team. We can talk about what we hope to achieve for the year. And then we also do a raffle, basically, usually at our unveiling event, where we allow sponsors to come in and raffle off some seats in the car for our next drive day. They get to come out and get to experience it firsthand and get a real feel for what we're doing and come see exactly what they're spending their money on and helping out.
You notice they're keeping the car running so that the people who are going to help them make the next car work have a chance to go play with a little bit, okay? But also use that car as a piece of reference, too, in terms of what you did right, what you did wrong. As compared to pulling the car all apart and selling out to an alum or whatever like that, it's good to have it around as a reference piece. The other thing you did is a 6 Degree of Freedom simulator, okay? Tell us about the development of your simulation. It's actual in-car simulator.
Yeah, so that was something new that we started this year. In the past, we started working with static simulators, and we basically, for this year, we used one of our cars from a few years ago and incorporated the steering and pedals into it, and we use either R Factor or Lift for Speed to create the courses that are seen out here once they're released. And so we've been doing static testing or static simulators to get the drivers up to speed, and we found it helps in the past. For this year, as one of the senior projects that we had going, we started working on incorporating a 6 Degree Freedom driving simulator, so we can actually replicate the feel that you're actually going to see in the car to give even more feedback to the drivers.
Any other comments? How'd you do in the simulator?
Okay.
Well, they select the drivers. Okay. The other thing is Steve mentioned earlier about your brake setting. You used data for that, but it wasn't just to get the feel right. It was to get the balance, the brake bias correct, and you're into the mode of getting all 4 tires to get as close to the limit as possible. It's easy to forget the most powerful system on your car is typically the brakes, not the powertrain. So getting that right, you're really taking advantage of basically almost free G-forces if you can get the balance set properly. So good job on that. Last thing I want to mention is that a number of judges thought it was quite good to see, it was refreshing to see. You did a lot of analysis using second and third order outcome review. So if you made an adjustment, what will necessitate an adjustment in another area as a result? So for instance, if you had chassis stiffness, you change that, you suddenly have a difference in steering sensitivity. You have to go back and adjust the steering box and so forth, or change the caster and so forth. So you're looking to see not just, I made this adjustment and it worked. No, I made this adjustment, but if I then paired that adjustment with another adjustment, it worked even better. So, and it's not usually just 2 variables, it could be 3 or maybe more variables. But that means having a command of vehicle dynamics and how that works, and you all have demonstrated that quite well. So, congratulations. San Jose State.
Okay, so any of you that know me understand I'm a power guy. I'm all about the power. And I got to tell you, every time I look at a Wisconsin car, I get pretty excited because they know power. Unfortunately, this car isn't powered by gasoline molecules, it's powered by electrons. But I've come to understand that I can maybe get even more excited about an electron-powered car because this car is pretty special. It's got 4 motors on it, and it, when the controllers are working correctly, it practices electronic differentiation, or vectoring, torque vectoring. And when you think about this, it's pretty unique because I've been involved in motorsports for, I don't know, plus 40 years or whatever, and particularly involved in rally and road racing, and in rally in particular with a small little turbocharged 4-cylinder all-wheel drive car. The drivetrain is really important, and the characteristics of the front, the center, and the rear differential on your rally car really determine how well the thing is going to corner, accelerate, brake, and maybe even flip over if you're not careful. All of the stuff that I've learned over my career pretty much goes out the window with this car because there's not a mechanical adjustment for the torque vectoring on this. It's all electronic. And some of the characteristics you can get torque vectoring to do via electronics is far beyond what I could have ever dreamed about back in the rally days with purely mechanical torque sensing devices. Wisconsin pretty well went on a limb. Well, they didn't really go out on a limb. They had an idea for what they wanted to do, and they executed it extremely well. So their car weighs 506 pounds. It's also a pretty, for being an electric car, 506 pounds is pretty special. It's pretty lightweight. They paid particularly close attention to the torque charts and checklists that go with the electric motors, and they did a detailed gearbox loss analysis during drivetrain loads. So this is not just an electric drivetrain, it's an optimized drivetrain that they paid particularly close attention to. They sized their motors based on loads, and the motor selection is really well understood. They didn't just look at 1 or 2 or 3 motors. They looked at every motor they could find. And I guess at the 300-volt range, from what I understand, it's kind of slim pickings. It's a whole lot better when you get to 600 volts, and we'll keep lobbying the SAE to get back with the 600-volt standard, but that's another argument for another day. So let me say that again, SAE. I think that the students in this room really want 600 volts, right?
Did I hear take the restrictors off too? Is that what I heard?
Okay, so Wisconsin's a pretty mature team. They've been around the block once or twice. They know how to find their way to the winner's circle with the gas molecules, and I'm sure that they're going to do the same with electrons shortly. Won't be this weekend, but they had, well, from what I understand, they had a control board failure on the 2 front motors, which put them on rear-wheel drive only, but they still were able to torque vector the 2 rear wheels, so there was torque differentiation electronically controlled. They have a very thorough understanding of loads, and this comes from all of the experience that they've had over the years doing some really great gas-motored cars. This car is extremely stiff, low compliance structure, and they paid particularly close attention to lightweight, strong design. Their targeted frame stiffness is very well understood. The team's pretty switched on. The car is very comfortable to sit in, although the 5th percentile female would not agree with me on that. But if I had to drive this car, I guarantee you, with all the electric motors running, I could make this car go really fast. It excites me to be looking at something like this that, it's the wave of the future. The one comment that maybe didn't surprise me, but you get these little pearls out of design judges every once in a while. Here's one. Great depth, understanding, and data confirming of calipers, okay? Best I've ever seen. This car has some rather unique front brakes on it because it's got wheel motors that are on the inside of the wheels, And they've got small 4-inch diameter, 1/4-inch thick steel rotors. They're hardened stainless steel rotors on the outside of the wheel with a custom designed 4-piston caliper. Now, when you drop the rotor size down on a front rotor application, you got to start squeezing this thing a whole lot harder because you've lost leverage because of the small diameter rotor. They realized this. They selected a particularly robust brake pad from a BMW MotoGP bike that will withstand the extreme pressure. So instead of increasing the line pressure to the front brakes, they did it in a very sensible way, and they put 4-piston calipers on, kept the line pressure under control, and brought the brakes into full integration with the car. It's a pretty nice, well thought out set of brakes integrated in with the wheel motors. I'm going to turn it over to Dave, and we're going to have a little interview with Wisconsin-Madison.
Yeah, a couple of things that was really interesting about this this team is the documentation is just incredible. I mean, anything you ask, they got a binder or a whole pamphlet about it. Like they've done this competition before sometime. No, they've won a number of times, so they know their way around. But it's something for all you to realize is there's only so much you can communicate to us as judges in 45 minutes. And yes, they'll show pictures, diagrams, the equations, everything is right there, rather than trying to just say it verbally. So very good at that. So they're really quite prepared. And also working hard at getting the underclassmen to be more and more involved in the team, so you don't wait until you're late in your junior year or senior year to really get going. They're working at making it literally. Students from 3 different classes typically are working in the car pretty much in earnest. They do a good job of training their drivers using the data. They've switched data systems. They actually had a vector system, which actually is a little bit clunky, not as elegant as I probably like, but they did it because they had a lot more processing capability, and they're looking to grow with it to do a lot more networking with CAN, and I think they'll do well with that. As Steve mentioned, the torque vectoring they do, it's not just that they did it, they understood the strategies. They showed vehicle dynamics-wise why they could apply more current to a corner and expect a difference in terms of the way the car handled. And they just had that down right. I'd like to bring Billy and James up from Madison. Okay. James is the driveline lead, okay, or drivetrain lead, I should say, and Billy is one of the technical director, okay, and handles the all-wheel drive systems, okay. First off, tell us more about your all-wheel drive system. Why you chose to bother? You know it was a weight penalty to do it. Why did you go with it? You went to compact motors, but it's a lot more complexity. Why did you choose to do that?
Yeah, so moving into building electric vehicles at our school for the first time, we really wanted to take advantage of everything an electric vehicle has to offer. So now you have the ability to put power in all 4 corners of the tire, start utilizing the full capability of each tire that you have in both cornering and in acceleration. So our design process starts for whether it's our combustion vehicle or the electric vehicle in lap time simulation, figuring out what size motors we should have, whether it's an engine or an electric motor for our vehicles. So figuring out based on vehicle dynamics, what size motors should we have, where should we have them, and how should we implement them. I think the most exciting thing we did in this vehicle is we set a really aggressive timeline saying we're going to go all-wheel drive in our first season, but how we did it was really breaking it into 2 separate systems, an in-hub motor system in the front and a rear drive unit inside the rear frame. So me up front, James in the rear there. So basically doing that was allowing us to build a system that we had a lot of reliability with, so we could run rear-wheel drive no matter what happened, but also be able to take full capability of all 4 motors. So it was a little unfortunate we weren't able to drive all-wheel here at this competition, but all of our testing, we got about 61 miles with the vehicle running all-wheel drive, implementing those systems.
Yeah, and you validated it well. It wasn't just, we've done this, trust us. You showed the data. You actually had done it quite well. The other thing you focused on was more for design for manufacturing, okay? And you understood the cost implications of doing it right. Comment on that a little bit more, because you had to go through a whole bunch of servicing with this car in the last few days, and you came darn close to getting it back together for endurance, so most people just would have given up. So comment on your servicing and your manufacturing focus.
Yeah, so two things there. Serviceability. Obviously, we wanted to build a robust system that we could confidently bring to this competition even when different parts break. So being that we're one team that builds two cars, we work closely with our combustion program to develop suspension geometries and a monocoque that we can use on both vehicle systems. So an example of serviceability is if for some reason the front motors were to fail, we would be able to take the entire front wheel off at the A-arms and put on the combustion vehicle's front wheel with their brake setup. So we could bring just a purely rear-wheel drive car to competition. And there are all sorts of little examples about that. And then we also want to optimize for our vehicle systems. So from the back of the monocoque, which is the same with the combustion vehicle, we actually have custom built and custom designed rear frames for each one of the vehicles to optimize for the specific packaging that we have and the packaging needs that are drastically different between an electric car and a combustion car. From a manufacturability standpoint, I think everybody's familiar with this in this room. At some point, you've got to be the one who's actually going to be building the thing in front of you. So whatever you're doing on CAD, the harder you make it, the harder you're making your life when you have to build it. So we pursued several different manufacturing techniques for certain components on the car. One of the things I'm most familiar with is the rear drivetrain. We use CNC milling 6061 aluminum, as I'm sure most of you do as well. For the center portion of the housing, it would have been a 4-inch thick piece of billet aluminum that I would have started machining down from, and that sounded terrible. So I started looking at different opportunities with 3D printing using DMLS out of aluminum, as well as lost foam casting, and I pursued both of those opportunities to create a lost foam cast center portion of my gear housing, as well as a 3D printed thing and portion of my housing. And I was able to directly compare the pros and cons of each one of those processes and save myself a huge amount of time by just having to do a small amount of post-machining. So, always thinking about how can we streamline our processes and learn as much from these experimentations that we're doing.
Yeah, it's so important because you want to be able to be in the competition and run, of course, and you didn't give up. I mean, it was always quite close, and I saw what was going on this morning when you're sitting there getting some moisture that got in your accumulator. You're like, hey, how'd that get there? I've never seen that before, and you were working at it. One of the things that impressed me when I talked to you on Thursday a bit, and also a little bit yesterday, is that when you went and did validations, there were cases where the validation didn't match what your predictions say by quite a bit. And you said, what do we do? And you actually came back and said, hey, this is our learning process. This is our aha moment. We had to just push it through because that's what our computer model says. You came back and said, no, we obviously had an error in our model somewhere, and you didn't just push it through. So that's part of the learning process. I said before, sometimes you got to fail a little bit to kind of get to the next level again. So again, fantastic. I'll be quite honest with you. What we've done with this car is really reminding what we see with some of the European cars that have come over and done well. It's not just the physical car, I've often said. It's just the way your whole team dynamic is working. So again, kudos to you, and you deserve to be up here. Okay, congratulations.
Thanks so much.
Thanks, guys. Okay, the last car I'm going to talk about tonight is from the Universidad Estadual de Campinas Unicamp. This is an electric car that took a different path. It's small, it's lightweight, it's 435 pounds. It uses a single electric motor and a conventional Drexler differential. It's a drastically simplified drivetrain. If you look at the back of this car, it's almost empty looking. It's really simple, okay? It's easy to build, it's easy to service. Particular attention was paid to serviceability. The team very, very clearly understood the minimum tube size rules that we have. What else? What other comments have we got? Very few fasteners of different sizes were used on this car. It's extremely easy to work on. They examined different transmission efficiency versus tripod angle. So again, this team is also looking at efficiencies and drivetrain losses, and they compared transmission efficiency versus tripod angle. And it's just one small factor that you look at when considering the overall drivetrain. Once again, we mentioned one of the other cars that got a set of parts from a well-known manufacturer that were out of spec and didn't work. This team did not confirm off-the-shelf parts because they were from a proven race supplier and they got bit. The part wasn't made properly. If it's one thing that I can emphasize and maybe overemphasize to all of you, don't take it for granted that just because it's a big name part like a Brembo brake rotor or something like that, that it's made correctly. Every incoming part that we sell through my facility, if we don't make it, we inspect it before we turn it around and add it into our part package. It's just one of those things you don't take for granted. So whatever parts you're putting on your car, check them. They did a brake proportioning valve and a pedal system that was designed to meet targets extremely well. Once again, the brake systems on all four of these cars are just extremely well done. There's been times in the past when teams kind of look at brakes as an afterthought, and they aren't that great as long as they pass the brake test. And by the way, when we go out for the brake test, we put the crappiest dry rotted tires on we can so we can easily pass brake test. These guys are paying attention. It's got a pretty nice brake system that's on this car. It's a lightweight, easily constructed tube frame car. It also uses a fabric body. It's an attractive little car. You wouldn't mind putting this in your garage and driving it on the weekend. I think it's a pretty effective little package. Dave, you want to take it away?
Yeah, a couple things. By the way, this team has been here before. They hold the record for the highest ever point score at this competition. Not this year, but 2013. That was unique because they were the only car that was able to actually run that year. So they've been around the block a bit. And then what they did is they came back in 2014 with a bunch of people gunning for them, and they won again. Okay? So they know how to win, right? 2015, the team was almost gone. They're pretty much down the dumps. They were not able to really conserve even be able to compete, and it was a shadow of itself. They weren't nearly as good after that, and they admitted that. You know, the two students here we'll talk to in a second. We'll probably talk to you about that. But they've regrouped. They're now up to about 55 members of their team. They're working hard. Their budget isn't incredibly high, but they're resourceful. And what I was impressed with is when I talked to them about some of their team dynamics, they said, you know what? We always have to work on the foundations. We've got to work on the fundamentals of the engineering rather than getting all caught up in all the different doodads. So I give them great credit for that because their fundamental vehicle dynamics are quite good. How many of you watch a Formula One car spin out when the regen doesn't work right? These guys are accounting for some of that. They changed their brake balance based upon the regen value. Okay? So they're not just doing front-rear bias. They're saying, hey, when the regen is on, we do a different bias to the rear than otherwise hydraulically. They're thinking. It's fundamental. They didn't have to get all jazzed up about it. They just went through and says, what's the fundamental? If you come look at the car, you'll see it's built relatively simply. The connections they have, particularly for the high voltage, are done in such a way you can't hook things up wrong. Each connector is very unique. So good kudos to that. Of course, you put a lot more wires on. It's going to be tough to do that. But at this point, they're very good about that. It tested everywhere they could. Steve said the fastener size inventory they kept low just so that they didn't have to carry a whole bunch of spares of different sizes. So that was done well. It's a tube frame, but they did do some work on some of the mesh for their skin and in some other areas. And they actually checked for different size meshes. They went down to a 1 millimeter mesh and determined that was best in terms of reliability. There again, it wasn't about do something because someone else did it. They did it. This makes sense for us. 435 pounds for an EV car is pretty impressive, and they just got the fundamentals correct. I'd like to bring up Abdallah and John from Unicamp. Tell us about what happened in 2015 and why you're up on the stage here in 17, less than 2 years. How do you do that?
Well, first of all, my English is not that good, so sorry if I misspelled something. I will try to express myself as best as I can. Well, answering your question, in 2015, our team almost ended. We were in 13 members. The team was founded in 2011 and built an electric car that was based. The fundamentals of the team are the same until now. We try to make a light car, reliable and simple. This is an important part of engineering, and the team was founded based on these principles. And they built a car. They won the competition of Brazil. They won the competition here with the maximum points, record of points, but they were the only one that finished. But that's okay. And we tried to lower the mass to 2013, and the car was like very light compared to the interior project. And we came here, we win in Brazil, and the good members of the team just left. They graduated, and there's nobody left on the team, nobody that knows nothing. So we have to rebuild our team, and this is the result. We're here again, we're happy with what we achieved. And unfortunately, we couldn't finish the endurance, but we're happy with our results. We're very honored to be here in Design Finals. It's a great honor for us, and that's it.
Thank you, John. Abdel, tell us a little about the EV design, what you did, because you had to work very hard. You have been very robust with the design. It's been quite reliable for you historically. Tell us what you've been doing to make it above and beyond.
Okay. First of all, we just choose our motor and our battery, and then we need to make sure that it will be reliable, because we have a lot of electronic devices in our car, and I don't know if everybody know that, but this stuff just stopped working at all. And you need to reset it. Okay, it's like our computer. When it stopped working, your Wi-Fi, you just take it off and turn on again, and yeah.
Wait 10 seconds.
Well, wait 10 seconds, and oh yeah, okay, it's time to. So we start to think about how to make it more reliable and more lighter, because it's a lighter car. Like I don't know pounds or something like that. I just know kilograms. Sorry, but it's less than 200 kilograms. So if you take off a kilogram of our car, it's the best car. No. So we start to change all the electrical harness, all the connectors, using more reliable and automotive connectors, just to make sure that nothing goes wrong. So that's our, and it goes wrong. Okay.
Well, design was done before endurance, so you're okay. Okay. Yeah, so I mean, there's a certain amount of honesty to the approach of what you're doing. You realize not everything's going to work, so you build it robustly so that when things fail, for the most part, it will continue to run. They built their own data logging system. Okay, it's a little expensive to go buy one, so they built one and used it very effectively for both the driver as well as the vehicle development. So, again, congratulations and
thank you.
Good luck to you. Unicamp.
Okay, so do you not know who won? We're going to keep you in suspense for just a little bit longer.
We lost the envelope. We've got to find the envelope. So, yeah. I do want to cover something here. What we're going to do is a little different. I can tell you the winners right this minute. We're going to roll this right into the final ceremonies, and we'll be giving the awards for design prior to the official start of all ceremonies. So, but there is one thing I want to cover. If you went over to the design building yesterday and late in the day, Thursday, which half of you should have been there in the afternoon, you will have seen these large D-size drawings up there as 3-view drawings. And I want to mention a little something about that. Your design reports, as you know, require that you have no more than 8 pages and 3 of those should be a 3-view drawing. A front view, side view, top view of the car. And most of you supply that. Most of you, okay? But we do give an award for that, and this year we've got an award I think you're going to like quite a bit. It's some of the Carol Smith books. And why do we bother with a 3-view drawing? In this day of CAD, what's the purpose of 3-view drawing? Well, not everyone has the same CAD system you have, and one of the suppliers you may be working with. Sometimes to view it, it's good to print it out and take a good look at it. And sometimes to get a good perspective. You can stretch things out with CAD, you can pancake it, you can twist it, do all kinds of fun items, but you cannot always get the perspective you need you can with a 3-view drawing. It's kind of I hate to say it's a lost art, but it's something that used to be absolutely mandatory if you want to be a decent engineer. But getting the dimensions and so forth there are very helpful. And frankly, we can't always read a CAD drawing from you as design judges either. So having a good, clear drawing helps us see a bunch about your car in the months prior to this event. So the requirements for the 3-view drawings, they must be line drawings, no shading, photorealism, or rendered images on the 3-view drawings themselves. You have an extra page for that. It's a free page in the report. You should include a title block with your, a school name, a car number. We've had 3-view drawings. We have no idea whose it is, except if we have the design report attached. But when we print them out, you wonder whose they were. Fundamental dimensions: the width, the height, the length, obviously, wheelbase, etc., should be in there. If you had a chance to look at some of those, I think you'll find that it's very well done. And I think we're going to work towards making the 3-view drawings publicly available for all you shortly here now too, because it's something you can all learn from. You're not going to grasp every detail of the competitors' cars, but I think it'll be very helpful for you to see those. So if you didn't go over there and take photos, which most of you probably did, we're going to figure out a way to have them available for you to see. Okay. So can't give you awards for all 108 3-view drawings we looked at, but we will for the top 10. I'd like one of the representatives of the team to come up and get their award when we do this. 10th place is car number 4, Missouri University Science and Technology. Are they here? They're not here? Okay. I thought my library just expanded here. Congratulations. Thank you. No awards, right? Number 9, or the 9th place is car number 41, University of Colorado at Denver. Are they still here?
Not actually me, but
What's that?
I'm
Okay.
not the one to, but
Go get it for him. Okay.
Thanks.
Congratulations.
Thank you.
Okay. 8th place, car number 14, Cal State Northridge. Nicely done. Good job. There you go. Okay, 7th place, car 101, Georgia Tech. Georgia Tech here, and a representative still here? Okay, I think they had a problem earlier, so we'll set this aside. Give that to another one. Okay, next one has actually been up here a number of times for this. McGill University, car number 204, EV car. Okay. All right, next was car number 99, San Jose State University, internal combustion car. I think they're here. Okay. Here you go. Okay, now, that was car number 99. Fourth place, San Jose State University for their electric vehicle. No, just give me, we got the one extra? Third or fourth? Fourth. You got the one extra? Yeah. Okay. That's right. Yep. Are they here? San Jose State EV? Yes, here.
You do have the ribbons?
Just hold on a second. Okay, third place, and actually it's a 3-volume trilogy of Carol's books, is Car 10, Wayne State University. Okay, second place for the 3-View Drawing Award is Car 28, University of New Mexico. Okay, my library is growing. Okay. All right, and the champion this year for 3-View Drawings was car number 110, Western University. Good job. Okay.
You're going to have each team come up on the stage, and you're going to do second place, then first place? Tradition.
We have 3 places for the. We'll just do third. Can we bring up one at a time?
Yeah, you're going to have to do it second place, then first place, then second place, then first place.
No,
Each team comes up on.
Bring them up one at a time, third, second. Okay. Are we ready for our next deal here?
Second place EV.
We have 3. Yeah, first, second, third, right?
Yeah, you're going to announce third, but we're going to get rid of second.
But we have them all, right?
Yeah, we have more. We have more.
Okay. What we want to do now is provide the trophies for the top 3 teams for the EV category. And we'd like to do is bring up the third place team and take the photos and so forth for University of Pennsylvania. Come on up. UPenn is a former champ here, so we knew you'd be good, and you were. All right, our second place team in the EV category is car number 211, Unicamp.
Come on up.
Okay, so this is what it's all about here, huh? The Piston Cup right here. Okay. All right, first place, engineering design for electric vehicle is car number 221, Wisconsin-Madison. They said the blueprints for their car will be available by 5 o'clock tomorrow. The blueprints for that car will be available for you all. Okay, so now we shift to the more traditional combustion category. And we had 6 finalists in combustion. And I'd like to list all 6, but I'd like the top 3 to come up here when we get to the trophies, the 3 trophies we have here. But I want to mention our finalists because it's tough. This competition keeps getting tougher and tougher. We had 77 cars to compete in combustion this year. And all these teams did an exemplary job to make it into the finals. So for 6th place was car number 3, Cal State Pomona. Get no trophy for that. In 5th place is car number 95, University of Illinois in Champaign. Fourth place is University of California at Berkeley, car number 51. Okay, the third place team here. If you give away the wrong trophy, you get to keep it, right? Okay. So third place is car 107, Virginia Tech. Nice job. Didn't anticipate being up here. You're back of the room, huh?
Thank you.
Good job. Way to go. Congratulations. Okay, second place team is car number 23, Texas A&M University. Okay, and so the top team here in the internal combustion category is car number 99, San Jose State University. There you go. Congratulations. Good? Yeah, we're good. Okay, so that concludes the design area. I think we're going to move into ceremonies. Are we ready for the rest? Okay. Then we are out of here. Congratulations, teams. Actually, all of you that participated here are way ahead of those who didn't make it. So very good job coming out here. It's a lot of work, and we think what you guys did is all actually really good work. And just keep it up. Just keep moving to the future, and we'd like to see you back again next year for both Michigan and for this event. Take care.